Hello everyone, the problem that we're going to discuss in this video is find a node to root path in binary tree. Let's see what we are asked to do in this question. So we'll be given a binary tree, let's say 50, 25, 12, 37, 30, 40, 75, 60 and 78. Okay. So suppose we are asked to find 40. We have to find 40 in the given tree. So we have to return if it is present or not, and along with that we have to return an array list containing node to root path, that is 40, 37, 25 and 50. Okay, this is what we have to do. So what will be the fate of our question? It is that I'll ask my left child to go and find if 40 is present, and I'll ask my right child to go and find if 40 is present. And before this, what I'm going to do is I want to compare myself. That is, I'll compare myself with the given data. Okay, this is what I'm going to do. If it is present, I'll return true. If it is not present, I'll return false. And then I'm going to add all the roots from this node till root into the array list and return. So let's just first look how find works. Let's write the code and then we'll come back and try run it. Okay. So let's just code it. So what did I say? We'll ask our left side. So left answer is equals to find and not dot left and data. Okay. I'll check what if the answer was present in my left tree and I got the answer. So if I get the answer, that is, if it is found, then return true. Because there is no point in searching it on the right side if it is already found. Now, Boolean right answer is equals to find not dot right and data. Now, if right answer, that is, I got my answer. That is, I got my answer. I'm supposed to return true. Also, I'm going to compare myself with the data. So, if node dot data is equal data, return true. And if the data we are searching for is not present in the tree, then return true. Also, we have to look for one base case, which is if node is equal null, return. This is all what we have to do. Okay, now what we'll do is we'll try to dry run this and look what is actually happening. Okay, so what I'm going to do is I'll take this part of the code and then we'll discuss it. Okay. Let me just give me a second. Okay, I hope this is visible to you guys. Okay, let's just throw this tree over here. We're having 50, 25, 12, 37, 30, 40, 75, 60 and 78. Okay, this is our tree and we are asked to find 40. We have to find 40. So we are here. we check if 50 is equal to data. No, it is not. So we'll look to the left side. Now we check if 25 is equal to the data. No, it is not. Then we look to the left. We see if now at this particular point, do you guys know where in the code we are? Okay, let's just divide our code. So this is, let's say, first line. This is second. This is third. Now initially we check if node is null, it is not null. Then we check if this data is equal to the data. It is not, right? So this condition is not fulfilled. Now we are moving to the left of 50. That is, we are for 50, we are here. Now for 25, we check if it is equal to the data. No, it is not. Now we look to its left. Now for 12, we are here. We'll check if 12 is equal to the data. No, it is not. So it will try to move to the left. Now the node is null, so it will return false. Okay, now it will move to line number 3. That is, it will look to its right. If data is, if it will try to move to the right side. Now it will check if node is null. Yes, it is, so it will return false. So from here also it will return false. Okay, now for 12, everything has been checked. Now it will move back to 25. Okay, for 25 up till here, the code has been executed till here. Now it will check in its right, that is the right part. Is this now 37? 37 is not equal to null, so 37 is equal to 40. No, it is not. So it will move to its right. Sorry, it will move to its left. 30. It will check, is 30 equal to null? No, it is not. Now it will check, is 30 equal to 40? No, it is not. It will try to go to its left side, right? But it will return false, since next of 30 is, left of 30 is null. It will come back. Now for 30, we are on line number 3. So it will go to its right and check, but it will return false since it is null. It will move back to 37. Now for 37, we have checked all the left side of 37. Now we'll move to the right side. We'll move to right side and we'll check, is 40 equal to data? Yes, it is equal to data, so it will return true. Okay, so it will return true. Now 37 will return true to 25. 25 will return true to 50, and it will return true. So this is how we found the answer. Now if you look, as soon as we received the answer, that is, as soon as we found 40 in the given tree, we return the answer and come out of the loop. Sorry, we come out of the calls. So if the answer is present on the left side, we don't have to check the right side of the, or right part of the tree. This is how, that is, only half part of the tree is being, it is being executed or being examined. As soon as we get the answer, we return it. So this is what we are doing here. Now we'll see how to find node to root path. It is same. As soon as we find the data, we'll add it to the array list and we'll keep adding it, right? So let's just see. Let's just first code it and then we'll do it. Okay, so same base case. If node is equal null, we don't have to do anything. We have to return an empty array list. So what we'll do is return new array list of integer. Okay, we'll return this, or maybe not. We don't have to write it. Okay. Return an empty array list. Now if node.data is equal data, what we are going to do is we'll create an array list. Integer answer is equals to new array list, and what we'll do is answer dot add data and return this answer, right? So this is exactly same as find, only we have to add the, as soon as we find the data, we have to keep adding it to the array list and return that array list. Now we'll have a array list. We'll have an array list left. That is, we'll try to find it on the left side. Node to root path, and we're going to do node.left and data. Now if left is greater than left dot size is greater than 0, that is, we have already found the answer. What we are going to do is left dot add node dot data, and we are going to return left. Right? In the similar way, what we are going to do is we are going to do the same work for right. That is, we'll search for the data in the right, and if we found the data, then we are going to add it to the right and return right. And if not found in the entire tree, so what we are going to do is we are simply going to return new array list. We are going to return new array list, new empty array list. Okay, let's just once try to run it, and then we'll see how it is working. Okay, let's submit it. It works. So okay, now what we have to do is we have to drop down it. Let me erase this part and bring it here. Okay, this part, right? Okay, now let's draw the tree again. 50, 25, 12, 37, 30, 40, 75, 62, and 78. Okay, so now we have to find the node to root path for 40, right? Okay, we come here. 50 is null. No, it is not. It will move. It will now go to the next part. This is, let's consider this as 1. This is 2, 3, 4. Okay, so it will come to the line number 2. We'll check 50 is equal 40. No, so it will move to the next line, line number 3, and it will move to its left. Now again, 25 is equal to null. No, it is not. Is it equal to data? No, it is not equal to data. Now what? Now it is going to move to its left again. Now it will check if 12 is null. No, it is not. Is it equal to data? No, it is not equal to data. Now it will try to move to its left. Now at this point, node is null, and it will return an empty array list. Okay, cool. Now left dot size is greater than 0. No, it is not. Now it will move to its right side. And now when it moves to its right side, it will see that its right side is null, and it will also return an empty array list, and the size, it will also return an empty array list. Okay, okay, now it will move back to 25 and with an empty array list. The left part till here, 425 till here, everything is being done. Now it will move to its right side. 37. Now 37 is not null. Is 37 data, is if 37 equal 40? No, it is not equal to 40. It will move to its left side, 30. Now is 30 equal to null? No, it is not. Is it equal to 40? No, it is not. So it will try to move to its left, right? But it will return this left side of 30 is null, so it will return an empty array list and its size is not greater than 0. Now it will try to find it on its right side, but right side is null, so it will return an empty array list. Now 30 will move back to 37. Now for 37, the left subtree part has been done, that is, it has been done till here. Now it will move back to 40. Sorry, it will move to 40, that is to its right side. Now, is 40 equal to null? No, it is not. Is 40 equal to data? Yes, 40 is equal to data. So, it will return 40. Now, when it moves back to 37, left dot size is greater than 0 because there is already 40 in the array list. So, the size is greater than 0. So, it will add itself, that is 37. Now, 37 will move back to 25, right? That is from this part, because 37 is the right part of 25. So is right dot size greater than 0? Yes, it is, and it will add itself, that is 25. Now 25 will return to 50. Okay, that is the left part, because 25 is the left part of 50, right? So now left dot size is greater than 0. Obviously it is. So it will add itself and it will return. Now this will be returned. So I hope you guys have clarity about how find is working and how node to root path is working. Thank you.